So, when asked to prove by using principle of mathematical induction, we use this formula for proving many problems in the world. For example, you may be told to prove by mathematical induction that 1 cube plus 2 cube plus 3 cube up to plus n cube is equal to n square into n plus 1 squared over 4. So this is what we do. For all being an integer, that is, we know very well that this can be abbreviated, but for all n, an element greater than or equal to 1, therefore we will follow up the following steps. We know very well that n is equal to 1. So let us start with the left hand side. That is equal to 1 cube will just be 1. According to right hand side, now when we go to right hand side, we will replace 1 squared into 1 plus 1 plus 1 squared over 4. 1 squared is 1. 1 plus 1 is 2. 2 squared, that's 4. 4 will go with this 4. Therefore, our final answer will be 1, which this one is also equal to 1. Also, we know very well that when we go to step 2, let us now take n to be equal to k. Therefore, p is equal, p of k will be equal to 1 cube plus 2 square, 2 cube plus 3 cube up to plus k up to plus k cube will give us k square into k plus 1 squared over 4. Yes. When we add k plus 3, then we cube it in both sides, then it will give us this one. It will give us 1 cube plus 2 cube plus 3 cube plus k cube plus k plus 1. Our k plus 1 is this one in bracket, so you bring it here and add it to both sides. Cube should be equal to k squared into k plus 1 squared plus k plus 1. Then, but this our k plus 1 is cubed. This one you divide by 4. Operating it will give us this one, that will be just equal to k plus 1 squared, you multiply it by k over k cube over 4 plus k, but this k, we are just expanding the bracket, we are just expanding that one, that is same as 4k, because we are expanding the bracket. 4k plus 4. Therefore, as we continue, we know very well that this is same as k plus 1 squared into k plus 2, k plus 2. As we continue with this one, you realize that our final answer will be k plus 1 into k plus 2 squared over 4. No, this is a case for n plus k. The proposition is therefore n is equal to 1 and is true for n is equal to k plus 1 for k an element of 2. Therefore, it is true for all values of n is equal greater than or equal to 1. We can also use the principle of mathematical induction to prove the proposition that all that you can cross across your answers